Okay, so in this video I'm going to show you a higher resolution version of the model that I showed at the end of class today, February 5th, 2014. This model shows the relationship between equipotential lines and electric field lines. So if we, you can see there's a transparent cover which has red electric field lines written on it, and we'll talk about those in a moment, but I want to start by concentrating on what's underneath. You can see that there are a series of foam layers that have been glued one on top of each other. Each one of these foam layers is meant to represent a different voltage. So let's say if we define this level to be 0 volts, then this level might be 1 volt, 2 volts, 3 volts, 4 volts, 5 volts, etc. And let's see, I think we started here, that this layer was 0 volts, so that means that this one would be -1, and this one would be -2. And then we can keep on going down, -3, -4, -5, -6. So remember that there's this close analogy between voltage and height. And so we get the freedom to choose where we want to define the voltage to be 0. And we can have negative voltages relative to that and positive voltages relative to that. Just like in a gravitational potential energy problem, we get the freedom to choose where the height is defined to be 0, and there can be negative heights at places that are lower than that. So here is a place where the voltage is quite positive compared to this level where we're defining to be 0. Here's another place where it's quite positive, and here's a place where it's very negative. If I look at the situation from above, you can see, if you just look at the edges of the layers, those edges correspond to the equipotential lines. So, for example, all along this edge, the voltage might be 1 volt all along this line. If I were to put a positive test charge on the side of this mountain, as it were, or at this point, in terms, so when we look at it this way, this I want to emphasize that this is, we're plotting voltage in the z direction, so the z direction is upward, versus x in this direction and y in this direction. So this is a plot of voltage shown in the z direction versus x and y position. So if I were to put a positive charge at this point, a positive test charge at this point, it would move down towards lower voltage, just like if I were to put a ball at this point on the side of a mountain, it moves down towards lower height. So we know it experiences a force in the direction that decreases the voltage the most quickly, just like a ball experiences a force in the direction that decreases the height the most quickly. And if we look from above, we can see that corresponds to the direction of the electric field line, that the electric field line points perpendicular to the equipotential lines and always in the downhill direction. In this particular model, this is showing the equipotentials and electric fields created by a set of 3 point charges. Here, this is a positive point charge, this is another positive point charge, and down in the valley there would be a negative point charge. So you can see the electric field lines, which always go downhill, are diverging away from the positions of the positive point charges and converging towards the position of the negative point charge. So hopefully this fly-through of this model will make things a little bit more clear for you guys, and I will pass this around in class on Friday so you can examine it even further.